All right, welcome everybody. This is 7.2, multiplying expressions containing exponents. So basically we're saying we have two expressions. We have y to the fourth and we have y to the third, and they're being multiplied. We're going to try and figure out what happens when we do that. What happens to the exponents when we do that? Okay, this is called the product rule. Another way to say that is multiplication rule. So if we're multiplying like bases, like here we have a y and a y, if they're the same base, what happens when we multiply them? What happens to their exponents? So to do this, what we're going to do is we're going to expand the expressions, and then we will simplify them, and we're going to see if we can find some sort of pattern. We're going to skip these first top three, mostly because like on your test and on your homework, I think most everything is using variables. So let's just get straight into the variables. Okay, so here if we want to expand this, I'm going to use two different colors for like the two expressions. So for this expression, for this blue one, we're going to expand that. That's, again, y to the fourth is just y being multiplied by itself 4 times. Okay, and then we're multiplying it by y to the third, so that's 3 more y's. So how many y's do we have in total? We have 7. So that would be y to the 7th. So y to the fourth times y to the third is the same as y to the 7th. All right. So maybe perhaps you already come up with some sort of idea of what happens to the exponents when we multiply like bases. Let's try another one. Okay, so when we're multiplying expressions, we multiply the coefficients just as normal. So we have 5 times 2, well, that gives you 10. So we have that out in the front. And then for the x, the first x, that's just 1x. And then for the other x, we have x squared, so that's 2 x's. So how many x's do we have in total? We have 3, so that would be 10x to the 3. So I'm just going to write that here so we can kind of look at that a little better. All right. Again, I guess I didn't mention this before, but if we just have an x by itself, like this expression, it has an exponent. It's just the exponent of 1. So whenever you have a variable that doesn't have an exponent, it's always a 1. So if that helps, then you can always do that. Okay. Last but not least, give this one a try on by yourself. Pause the video and see if you can do this by yourself. Oh wait, just kidding. Let's do this together. Okay, so this one's a little different. So here we have our coefficients. We multiply those as normal. So -3 times 2, well, that gives us a -6. All right, now we have y squared. So this is a little different. That's y times y. And then we have 5 x's. Okay, so since the bases are not the same, we can't combine the y's and the x's. So when we're all done, we're end up getting -6y squared x to the 5th. Okay, so one thing that's important to know is we can only combine these expressions if they have the same base. Okay. All right, so let's look at this. Have we come up with a pattern? Looking at these two especially, what do you notice about the exponents on the left side and the exponent on the right side? So we had 4 and 3 on one side. On the other, we have 7. Okay, so think about maybe some sort of pattern, or how do they combine? Okay, here we have x to the 1. We have a 1 and a 2 on this side, and we end up getting a 3 on the right side. Okay, so hopefully you've come up with some sort of idea that when we're multiplying like bases, meaning both of the bases have the same variable, like x and x or y and y. Okay? When we multiply like bases, we add their exponents. Okay? Like a generic way we could write this is we could say if we have something that's like x to the a, where a is just a number, times x to the b, which is just a different number, that would be equal to x to the a plus b. So if we kind of put this as a number, we could do like x to the 3 times x to the 5 is equal to x to the 8th. Okay, so this is just like an example, right? But this is basically the rule in an equation. This is like the rule in words. Okay, so let's use that to come up or do some of these examples. Okay, we're going to start by expanding them. All right, I want you to expand them before you do anything else because I feel like that's a good practice. And then once you get the pattern all set in stone, then you should be good to go. Okay, so to expand this, for this first example, well, we have y times y for the first expression, and then for the second we have y times y times y times y, 4 y's. So that will, when we simplify that, that gives us 6 y's, so y to the 6th. I'm just going to put it there instead of over here just so that we can see it a little better. So this is simplified. All right. One thing you need to notice is that before we expand anything, we have to get rid of our negative exponents. In our last class, we learned about how we handle negative exponents. Remember, if we have negative exponents, we switch it to be positive and we bring it to the bottom. Okay? So here we have the same as x to the 5th, so that will stay the same because it's not, the exponent is not negative, but the blue expression has a negative, so we'll need to bring it to the bottom and we'll change its sign. Okay? So you've got to do that before you expand. So now we can expand that, would have x times x times x times x times x all over, and on our bottom we have x times x. We have 2 x's. Okay? Now we can cancel out 2 of the x's, top and bottom, and that just leaves us with 3 x's, or x to the 3rd. Okay? So our rule here is that if we're multiplying like bases, then we can add their exponents. Another way you could do this, which might be easier, would be to do x to the 5th plus negative 2. So that was kind of our rule, that if we have 2 bases that are the same, then we can add 5 and the negative 2 together. So that would give us x to the positive 3. Okay? So different ways you can do it. Both are equivalent, both are good. You can choose which way you'd like. Okay. Here's another one, basically the same as we did above. Pause and give this one a try. So here we have a negative exponent, which means we need to rewrite it and bring it to the bottom. So we'll have x to the 3rd on the top still, because it didn't have a negative. The exponent's positive. But we'll need to bring down the x to the bottom and change the sign of the exponent. Okay. Now if you want to, if we want to expand, then we'd do like x times x on the top, and we'd do 4 x's on the bottom, and then we can cancel all of those that are on top and bottom, and that leaves us with nothing on the top. So if there's nothing there, it's just going to be a 1 over x. Okay. Again, if we do it the other way, which I probably prefer, if you can get to this point, then do this. Since they are being the bases are being multiplied, if two things are touching, then that's multiplication. Then we're going to add their exponents. So then that would be x to the negative 4 plus 3, and that is x to the negative 1. And then at that point, you would need to take care of that negative by bringing it to the bottom and changing its sign. So I think last time we talked about if a coefficient's not there, then we could always put 1 in the front. 1 times x to the negative 1 is the same as x to the negative 1. So we need to bring it to the 1 will stay, the coefficient will stay, and the base and the exponent would bring to the bottom and would change its sign. Okay, and that is the same as just 1 over x. All right. So again, you kind of have those two choices that you could do. You either expand and cancel things off, or you would kind of use the rule where we just add those exponents, and then since we have a negative here, we had to bring it to the bottom. All right, here's some other examples. If you're feeling like you're getting this, then I would pause and try and do as many as you can, and then go over with the video. Okay, so again, coefficients, they multiply as normal. So that's the same as doing 10 x to the third times x to the sixth. Okay, and if we expand it all out, we'd have 10, and we'd have 3 x's, and I have that be my red. And then maybe I'll do purple. Here we have 6 x's. So how many x's do we have in total? We have 9, so that would be 10x to the 9. And again, if you wanted to, you could just go from here and do x to the 3 plus 6, and that is also 10x to the 9. Same thing. All right, number 5. Here we have 3 expressions, and again, having a dot is multiplication. If you have 2 expressions right next to each other, that's the same as multiplication. Okay, so if we want to expand that, well, we have 1x in this expression. Here we have 3 x's. And then we have 5 x's. Again, probably the best way is just to, well, I guess we just add those all up together. That's 1 plus 3 is 4, plus 5 is 9. So here we get x to the 9. Okay? And again, if you wanted to do kind of like what we did above, the other way you could do it is just realize that this is x to the 1, and we just add all of those exponents. So 1 plus 3 plus 5, well, that gives you 8. So 1 plus 3 plus 5, and that's x to the 8th. Sorry, 9th. Sorry, my bad. Forgive me. All right, so here's another example. Looks like we have 2 more, and then we have some kind of like word problem-ish application type of a problem. All right, so let's give this one a try. Pause again if you would. Give this a try. First thing I notice is I have x to the 0. So that is just 1. So that's 5 times 1. Again, the 0 is only applying to what's touching, so that's just the x. All right, so you could simplify that if you wanted to, straight up. We also have these coefficients. We multiply coefficients just as normal, so maybe we can simplify that up. So negative 3 times 2 is negative 6, and negative 6 times 5 is negative 30. So maybe I'll just have a separate step for this. And again, x by itself is just x to the 1. So now we could expand it. That's 3 x's for the first term. And then we have a 1x Again, that's like a 1. And then for our last term, that's like no x's, so we wouldn't write anything for that. So that would just be negative 30 x to the 4th. Again, if you prefer to do it the other way, if we have our negative 30, and we had our x to the 3rd, x to the 1, and x to the 0, that's just the same as x to the 3 plus 1 plus 0. And that's negative 30x to the 4th. So we get the same thing, just depending if you want to expand or not. All right, last one. Looks like we have a couple negative exponents. And we have 2 coefficients. So let's first take care of that. Let's write that as 24. So 4 times 6 is 24. And then we'll have x to the 6th times x to the negative 2 times x to the negative 3. So if you use, if you expand it, you need to change those negative exponents to positive exponents. So if you do that, we'll still have our 24x to the 6th. And then we'd need to bring down our x to the positive 2 and x to the positive 3. So again, bring them to the bottom and change their sign. Then we could expand. Okay, and then we could cancel top and bottom, and that would just leave us with 24x. Okay. For this one, I think it's probably easier just to do what we did before, is where you just add the exponents. So that would be 24x to the 6th plus a negative 2 plus a negative 3. And if you did 6 minus 2 minus 3, that just leaves you with 1. So that would be 24x to the 1, or just x. All right, so choose whatever you'd like, whichever way you like to do it, and just stick with it. That would be my suggestion. All right, last but not least, 9 and 10. I'm going to do one, you try the other. We're going to find the area of this rectangle. All right, so again, area of a rectangle, or the equation for that, area, is equal to length times width. I know you've done this before, or at least you've learned about area. And all we need to do is choose which side is going to be length and which is going to be width. So I'm going to say this is going to be my, well, I'm going to do that being my width. This will be my length. It doesn't really matter. And then we're going to use our equation to find our area. So area is equal to length, so that's 3x to the 3rd, times our width, I'm going to change that color to be blue, 4x squared. So now we have an equation that we need to solve, and it's just like what we've done above, except now we had to put it into that equation. So we have 3x to the 3rd times 4x squared. Again, we multiplied the expression, or the coefficients as normal, so 3 times 4 is 12. And then since we have like bases, I'll use a different color now. X's are the same. We have the same base. We're going to add their exponents. So 3 plus 2 is 5. So x to the 5th. And that's your answer. Area is equal to 12x to the 5th. So give this one a try. We have 2 variables. Just remember that you can only combine if they have the same base. So here I'm going to maybe say this will be my length, this will be my width. So area is equal to length, so that's x squared y, times our width, which here is going to be x squared y to the 4th. So here we have like bases. That's x to the 2 times x to the 2. Well, that's x to the 4. So we just add. We add those exponents. And then for the other, we have our y's. We have two y's. Again, we can write an exponent of 1 if the exponent's not there. And then we're just going to add those two together. So that's y to the 5th. All right, so that's it. Please let me know if you have any questions. And we'll see you later.